All right, so we're going to start the Unit 8, which is a review of some special right triangles from geometry. So we looked at angles in degrees and radians, and so we're going to look at right triangles, special right triangles that are the 30, 60, 90 right triangles and 45, 45, 90 right triangles. So these triangles come into play when we look at the unit circle, which we'll do after we review these special right triangles. So on the 30, 60, 90 right triangle, you can see this pictured, and everything revolves around the 30-degree angle. So sometimes they give you the 30, and sometimes they give you the 60, sometimes they give you the hypotenuse, and that's the sides opposite those angles. And so we have these ratios that we can use to find the measure of sides if they only give us one side. Because remember, in a right triangle, to use the Pythagorean theorem, you need two sides to find a third side. Well, in 30, 60, 90 and 45, 45, 90, they usually will only give you one side. And so we can use these ratios to find missing sides. So the side that's opposite the 30 degree, if you remember, we call it U, or we can also call it the short leg. And then the side that's opposite the 60 degree, we can call that U times radical 3. Or we can also call that the short leg times radical 3. Or you can also call it the long leg. And then the side opposite the 90, obviously, is our hypotenuse. So in our 30, 60, 90, I'll just use the letter U because x's get confusing if we use x. All right, so opposite the 30, we're going to call that U. So this is just to help you out. I'll just put it over the 30. Opposite the 60 is U times radical 3. And then opposite the 90, we're going to call that 2 times U. So these are our ratios to each of the sides. All right, so let's look at this first one. So we have a 30, 60, 90 triangle. So the first thing that you always want to do is label which side is which. So opposite the 30, we're going to call that side U. And then opposite the 60, we're going to call that side U times radical 3. And then opposite the 90, or our hypotenuse, we're going to call that 2 times U. Now, of the three sides, they always give you one of the sides. So you just have to take whichever expression that you wrote, either u root 3, or 2u, and set that equal to the side that they give you. So in this one, they give us the hypotenuse, 8. So we know that 8 is equal to 2 times u, because they're on the same side, right? So they occupy the same space. So they're equal to each other. So what we want to do is solve for u. So we can divide both sides by 2. And we get u is equal to 4. So wherever u is now in the problem on our sides, we can put 4 there instead. All right, so we know 4 is over here, because that's where u is. And we know this side is 4 radical 3, because that's where u is also. So it's u times radical 3. So if we're trying to find the values of x and y, we can state x equals 4, and y is equal to 4 radical 3. All right, so again, x equals 4, and y equals 4 radical 3. All right, so let's try number 2. So again, we want to label our sides. So opposite the 30, call that u. Opposite the 60, u radical 3. Opposite the 90, 2 times u. So we got to find out which side they give us. So this time they give us 6, which is on the side of u radical 3. So we can set those equal to each other and solve for u. So we would divide both sides by radical 3. All right, so u is equal to 6 over radical 3. Well, we don't want to leave a radical in the denominator, so we multiply top and bottom by radical 3, and that'll get rid of that radical off the bottom. So when we multiply across, we get 6 radical 3. And on the bottom, radical 3 times radical 3 is radical 9, but that simplifies to 3. So radical 3 times radical 3 is just 3. Now we can simplify this fraction, 6 over 3, and so that's 2. So u, we just simplified to 2 radical 3. So now, wherever there is u in the problem, we can put 2 radical 3 there. So here, 2 radical 3. Here, it's 2 times 2 radical 3, because that's 2 times u, which is 4 radical 3. All right, so now we can state what's side x length and what's side y. So we can say x is equal to 2 radical 3. Y is 4 radical 3. All right, now with 45, 45, 90, the ratios are u, and u root 2. So opposite the two 45 degrees are just side u. They have the same length because it's an isosceles right triangle. And then the hypotenuse is whatever the leg is times radical 2. So u radical 2. So the ratio is u, and then u times radical 2. So let's see how we can use that to solve a 45, 45, 90. So number 3. So again, we want to label our sides. So opposite the 45, this is side u. Opposite the other 45, that's also side u. And opposite the 90 is u times radical 2. So now you got to find out which side they give you its length for. Well, we can see that the hypotenuse is 9. So we can set u radical 2 equal to 9. Okay, so this is the one I'm going to set equal to, so I'll just rewrite it right there. So u radical 2 equals 9. So now we've got to solve for u. So we're going to divide both sides by radical 2. So u is equal to 9 over radical 2. Well, we don't want to leave, again, we don't want to leave a radical in the denominator, so we're going to multiply top and bottom by radical 2. So on top, we get 9 root 2. On the bottom, radical 2 times radical 2 is radical 4, but that simplifies down to just 2. So u is equal to 9 root 2 over 2. So u is equal to 9 root 2 over 2. And there's our other u, 9 root 2 over 2. So then we can answer what is the value of x and what's the value of y. So x equals 9 root 2 over 2, and y equals the same thing. Okay, that makes sense because they're both the legs of a 45, 45, 90 right triangle. So the legs are always going to be equal. So once you find one, you actually have the other one. All right, so number 4, let's see, opposite the 45, call that u. Opposite the other 45, call that u. Opposite the 90 is u times radical 2. So find the side they give you. So here we can see that 10 is equal to u. So it's already solved. We already know what u is. It's 10. And so we have another u over here. That's 10 also. And then there's another u right there. That's 10. And if we multiply 10 times root 2, that's 10 root 2. Okay, so let's state what x and y are. So x equals 10 root 2. Y equals 10. All right, and let's go ahead and do these last two problems, 5 and 6. Just review again, 30, 60, 90. Right, so we want to label our side, so opposite to 30, call this u, opposite to 60, u radical 3, and then opposite to 90, 2 times u. Find the side they give you, so here they give us 12, and 12 is equal to u radical 3. So we're going to solve this for u, divide by radical 3 on both sides. Can't leave a radical in the denominator. Okay, so we have 12 over radical 3. We're going to multiply top and bottom by radical 3. So that's 12 radical 3 on top. Radical 3 times radical 3, again, is radical 9. That simplifies to 3. We can simplify this fraction. So that's 4 radical 3. So that's what u is. So wherever there's a u, put 4 radical 3. Well, on the x side, it's already done. X equals 4 radical 3. Now on the y side, we still have to multiply 2 times u, 2 times 4 radical 3. So 2 times 4 radical 3 is 8 radical 3. And that's what y is. All right, and then number 6, opposite to 30 is u. Opposite to 60 is u radical 3. Opposite to 90 is 2 times u. Find the side they give you. So this time they give us the 2u side, which is the hypotenuse. So we can set those equal to each other. Solve for u. We'll divide by 2. So it means that u is equal to 1. So put 1 in for all the u's. And so we can see that 1 times radical 3 is just radical 3. So we can see that x equals 1 radical 3, or just radical 3, and then y is equal to 1. All right, so now what we're going to do is practice filling out what's called the unit circle. So this is a circle that has a radius of 1. And then we can use our special right triangles, basically what we just learned, and how they're used to fill out a unit circle that has special angles. All right, so we're going to go ahead and practice filling one out, and then what I want you to do is try to practice doing as much as you can on your own when you do the homework one and you fill out another one. All right, so we're going to practice filling it out, and then later on in another lesson, we're going to see how we can use this unit circle to answer questions. So it's up to you on how you want to fill it out. Most people use patterns. It looks really complicated, but it really isn't. It's all patterns on this. So we have the angles that we have to fill out and the radians. Okay, and then we have the ordered pairs that make up these lengths. Okay, so think of these as if you were to draw a triangle, you have a length of x and a length of y. That's the sides of a right triangle, where our radius or the hypotenuse will always end up being 1. All right, and this is really important concept as you go higher in math. You take pre-calc or anything higher, this unit circle and trig keeps coming back. All right, so let's go ahead and do our angles first. So a lot of people put in their degrees. So we're going to start this at 0 degrees. So this is where the 2 rays lie directly on top of each other. And then we start to open it up and go counterclockwise, so in the positive direction. So that's going to be a 90-degree angle up there. Then we're at 180, would be halfway around the circle. All right, I'll come down so you can see. And then 3/4 of the way would be 270 degrees. And then as soon as we make a full revolution, we're at 360 degrees. Okay. All right, now if we cut a 90-degree angle in half, then it's at 45 degrees. And so you're going to have these three lines. This is where the special right triangles that we just learned, 30, 60, 90, 45, 45, 90, come into play. So that first line is going to be a 30-degree angle. And then the middle one's 45, and then the third one is going to be a 60-degree angle. Now everything basically just keeps revolving off of those measures right there. So between 90 degrees and the next one, right, that's going to be a 30 degree. That's 30 degrees in between. So what you want to think of, if you look at quadrant 1, the pattern is add 30 degrees to get that first line, then add 15 to get the 45, then add 15 to get the 60, and then add 30, and then you're at 90. So the pattern is 30, 15, 15, 30. 30, 15, 15, 30. So we're going to add 30 to 90, and we're at 120. Then we're going to add 15 to 120, that'd be 135. Then we're going to add 15 to 135, that'd be 150. And then we add 30, we're at 180. Okay? So hopefully that makes sense. You're adding 30, adding 15, adding 15, adding 30. And you just keep that same pattern going around. Okay, so we'll start at 180 and add 30, so that's 210. Add 15, so that's 225. Add 15, so that's 240. And if we add 30, we're at 270. Okay, now let's keep that same pattern going. We're going to add 30, that's 300. Add 15 is 315. Add 15 is 330. Add 30, we're at 360, one complete revolution. So that's how you get your degrees in. So start off at 0 degrees, and then just remember the pattern, 30, 15, 15, 30. And you should be able to walk all the way around going counterclockwise to get all the measurements for the angles in. All right, so now we're going to do radians. Now, we're going to always start off with 0 radians. So that's 0 radians. And we can put in, just like we did the quadrants, so 90 degrees, that's pi over 2 radians. 180 degrees is pi radians. At 270, that's 1.5 pi, or 3 pi over 2. And then one complete revolution is going to get us 2 pi radians. Okay, so half a pi, or half a circle is 180 degrees, which is 1 pi, and then double that, you're at 2 pi. So that's a complete revolution. 360 is the same as 2 pi. Right? And if you forget, remember, you can do your conversion. You take your degrees and multiply it by pi over 180. Okay, and that should get you the radians. All right, so the way that I memorize my radians, now you could, again, just multiply by pi over 180, but it takes a long time to do that. If you just memorize the patterns, it's actually pretty easy. So what I do is I put all the, you can see in each of the quadrants there's 3 lines. So the middle one is a multiple of 45 degrees. Well, the first one is going to be 1 pi over 4. Okay, so if you just memorize that middle line of the 3 is always going to be some multiple of 45 degrees, or pi over 4, you should be able to get all 4 of them in. There's 4 multiples of 45 in these quadrants. Right? So the first one's 1 pi over 4, and then the next one at 135, that's the middle line. Think of it's an odd multiple of pi over 4. So you're just going to think of, well, what's the next odd number after 1 pi over 4? Would be 3 pi over 4. Okay, that is what 135 degrees is. All right, and then what's the next odd number after 3? Well, it'll be 5. So 225 down here is going to be 5 pi over 4. And then the next odd number would be 7. So 7 pi over 4 is going to be the 315. All right, so you think of odd multiples of pi over 4. 1 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Right, now everything else, you can see it's 30 degrees is where we're starting. Everything else is going to be a multiple of 30 degrees. 30 degrees, 60 degrees, 120 is a multiple of 30 degrees, 150 is a multiple of 30. So what you're going to do is at 30 degrees, you're going to start it off at pi over 6. And that's what 30 degrees is. If you did the conversion, it's pi over 6. All right? So what you want to do is you're going to start to count around multiples of pi over 6. And then if you can simplify the fraction, you will. So we'll start off at 1 pi over 6, and then at 60 degrees, we're going to think of 2 pi over 6. Okay, so 2 pi over 6 simplifies to pi over 3. Okay, so again, we'll go back to the 30 degrees, pi over 6. Then at 60, it's 2 pi over 6. At 90 degrees, that's 3 pi over 6, but that simplifies to pi over 2. And the next number is 4 pi over 6, and that's at 120 degrees. So 4 pi over 6 will simplify down to 2 pi over 3. All right, so again, think of the pi over 6s. We're just going to keep counting up by 1. Okay, so again, I'll start back off at the 30 degrees. So 1 pi over 6. 60 degrees was 2 pi over 6, which simplified to pi over 3. Then 90 degrees is the same as 3 pi over 6. That simplified to pi over 2. And 4 pi over 6 simplified. The next one would be 5 pi over 6. And that's the 150 degrees. Then the next one would be 6 pi over 6. Well, 6 pi over 6 simplifies to pi. All right, so now let's keep going. So pi is at 6 pi over 6. The next number would be 7. 7 pi over 6. That doesn't simplify. The next number after 7 pi over 6 would be 8 pi over 6. 8 pi over 6 simplifies. 4 pi over 3. Then 9 pi over 6 would be at 270. Well, 9 pi over 6 simplifies 3 pi over 2. Okay, let's keep going. After 9 pi over 6 would be 10 pi over 6. That simplifies. 5 pi over 3. Then 11 pi over 6. That doesn't simplify. And then one complete revolution after 11 pi over 6, we'd be at 12 pi over 6, and that simplifies to 2 pi. All right, so you can see that all these radians, they have a denominator of either a 6, a 4, a 3, or a 2. And they keep repeating in the same pattern. Okay, so there's 2s, 3s, 4s, and 6s. Now, in this unit circle, one thing that's neat is if you take this, look at this pi over 6, you come directly across, you pick up another pi over 6. Okay, it has a pi over 6 also. Oops. If you take this pi over 4 and go directly across, it has a pi over 4. It's a 3 pi over 4. If you look at this pi over 3 directly across, it has a pi over 3. If you look at this pi over 2, it has a denominator 2. Directly across, it has a denominator 2. Right? You can come down here and look at over here at pi over 6, come directly across vertically down, you pick up another radian measure that has a pi over 6. Pi over 4, come directly down vertically, it's a pi over 4. Okay, a pi over 3 vertically, another pi over 3. So what that means is, and you can go diagonally too, so pi over 6, go along its diagonal, you pick up another pi over 6. So if you go vertically or diagonally or horizontally, those denominators always have to be the same. Okay, so you can't have a pi over 6 and then go diagonally and pick up a pi over 3. It's not going to happen. So they have to have the same denominator, either diagonally, vertically, or horizontally. All right. So now what we're going to do is look at how these angles, if they were put on an xy axis, how you get these ordered pairs, because they're going to intersect at a point on an xy axis. And I'll show you how we get them in the next lesson, but for now, we're just going to go ahead and fill it out, and then we'll start to memorize what they are. All right, so you think of the middle of this circle, we're going to put it at 0, 0. And if the radius is 1 unit in length, okay, I think you go out 1 unit, then it's going to intersect here at 1, 0. That's the ordered pair, 1, 0. And then at 90 degrees, I think if the radius is 1 unit, it would intersect at 0, 1 at the top here at 90 degrees. Okay, again, where the middle of the circle is at 0, 0. If we go left 1 unit, we would be at negative 1, 0. And if we go down vertically at 270, that's 0, negative 1. That's where that point would be located. All right, and then let's go ahead and fill out these ordered pairs. Like I said, well, I'll explain how we get these, but for now I just want you to see how what the ordered pairs are and then how they just repeat the pattern. So at pi over 6, its ordered pair is going to be root 3 over 2 and a half. At 45, it's going to be root 2 over 2 and root 2 over 2. And then at pi over 3, it's going to be 1 half and root 3 over 2. So if you look at the 30 degree and the 60 degree, they're exactly the same ordered pair, just they're switched. X became Y and Y became X. And on the 45, it's exactly the same ordered pair. You can also notice that all the denominators are 2. All right, and that's going to happen with all our other angles too. Now, if you think of ordered pairs that are in quadrant 1, they're always positive. Okay, all the x's and the y's are positive in quadrant 1. When we move over to quadrant 2, okay, again, the ordered pairs are positive, positive in quadrant 1. In quadrant 2, it becomes negative, oops, negative positive. Okay, the x's are negative and the y's are positive. In quadrant 3, both x and y are negative. So it's negative and negative. And then in quadrant 4, it's positive, negative. The x's are positive and the y's are negative. So we can use that to fill out the rest of the ordered pairs. If you know quadrant 1, then everything else, quadrants 2, 3, and 4, revolve off quadrant 1. So what you want to think of is, if you take this pi over 3, which is the 60 degrees, find another pi over 3, and you get the exact same ordered pair. It's just the signs are going to be different. So at 2 pi over 3, it uses the same ordered pair as 1 pi over 3. So it's 1 half, comma, root 3 over 2. The only thing that's different is the sign. So x is negative, and y is positive. So it would be negative 1 half, comma, positive root 3 over 2. Same with the 45. Okay, so we take the pi over 4 and go directly across to 3 pi over 4, and we get the exact same ordered pair. Except x is going to be negative, and y is positive. At pi over 6, it's going to be the same as 5 pi over 6. Except x is negative, and y is positive. All right, if we use that same pattern for quadrant 3, okay, 7 pi over 6 is going to have the exact same ordered pair as 1 pi over 6. So that's root 3 over 2, 1 half. Except both x and y are negative now. So we have to put a negative in front. On pi over 4, that's the same. 5 pi over 4 is the same as 1 pi over 4. Root 2 over 2, root 2 over 2. Except both of them are negative. And then 4 pi over 3 is the same as 1 pi over 3, which is 1 half and then root 3 over 2. But they're both negative. because they fall in quadrant 3. And then in quadrant 4, same idea. So if we want 5 pi over 3, find 1 pi over 3. Okay, that's the 60 degree. So that's a half root 3 over 2. But now y is negative. So it would be 1/2 comma negative root 3 over 2. For the 7 pi over 4, it's the same ordered pair as 1 pi over 4. So both root 2 over 2. But the y-coordinate is negative, and the x-coordinate is positive. And then 11 pi over 6 is the same as 1 pi over 6. So root 3 over 2 comes first, 1/2 comes second, and then the y-coordinate has to be negative. Right? And then that's how you fill out the ordered pairs, along with the degrees and the radians.